If you enjoyed the last video on microwave generation using a magnetron, please stay tuned. We're going to test this. Welcome back, folks. I hope you enjoyed my last video on running a magnetron. I'd partially taken that magnetron apart and ran it off a high voltage, low power supply to see if we could get microwaves out of it. Except it's outside of the microwave waveguide, and it's set up according to this standard circuit for microwave oven transformers. So here you have your microwave oven transformer, which is this big heavy duty transformer here. This thing can put out more than an amp at 2,200 volts. So it's very dangerous. So I have that here, and it has a couple of windings on it. It's got, the first winding is the filament transformer component. This is the mains going into the primary, and this secondary here puts out about 3.3 volts to run the filament. So you can just see that winding right in there. And these wires come out of that and supply power 3.3 volts to run the filament in the magnetron. And the filament is part of the cathode. And then the bigger secondary puts out about 2,100 volts. And this is the bigger secondary. Now this secondary, one part of it is connected to the core of the transformer, and the other terminal that's not connected to the core is right here. Now, they're wired up in such a way that your cathode, which is this, is basically floating, and your anode is grounded. So your positive anode is grounded, and that's a much safer way, an easier way to set them up. And so you have a microwave oven capacitor. This one's rated to use in microwave ovens, and it is rated for peak voltages of around 4,000 volts. Because you effectively have a level shifter here, where the secondary here puts out about 2,000 volts, which is stored up in this capacitor. And once this capacitor fills up, then part of the mains, which is an extra 2,000 volts, is on top of the voltage already in this capacitor, which effectively doubles the voltage across the cathode and the anode to around 4,000 volts, which is at the mains frequency of 60 hertz. And so at 4,000 volts, electrons flow from the cathode to the anode through a certain size diameter chamber. It's a metal chamber, and it's been cut to exact dimensions here. And the two magnets, the two opposing magnets, these are ceramic magnets on either side, cause the electrons to, instead of travel in straight lines from the cathode to the anode, they start traveling in a circular spiral type motion. Depending on the voltage, the velocity of motion changes. And so as they travel from the cathode to the anode, they pass a bunch of small little cavities that are cut into the walls of the chamber. And as these electrons blow past these cavities, resonance is set up, much like blowing air over the top of a bottle, where you can get resonance going in the bottle. The same thing happens with the little cavities. And as the resonance is set up, microwaves are generated and amplified within this chamber. And there's plates on the back here, so the microwaves are directed out of this channel here, this little waveguide here. And this is made of a ceramic material. It can be, it's most commonly aluminum oxide, but it can be made of beryllium oxide. I believe this one is just aluminum oxide containing some chromium salts that makes it appear pink. So here's your basic setup. And then the mains comes in here. The mains goes into a filter. So this will filter out any noise getting back into the house mains. And a very simple circuit, as you can see here. And a very dangerous circuit to operate outside of a microwave oven. So I'm going to test this, but instead of plugging this directly into the mains, I'm going to run it through a Variac, specifically this Variac. This one is rated for about 2 kilowatts. It's a Chinese Variac, and this one has worked really well. And I want to just see when I start getting microwaves, as I increase the voltage on the Variac. One of the things that's going to vary, however, is the filament voltage, because at lower voltages, the filament is going to be inadequately heated to allow electrons to fly off of the heated cathode. So I'm assuming that, as I get closer and closer to 120 volts, it's going to start producing microwaves. So let's begin our experiment. In order to view the microwaves and the effect on different objects, I'm going to use this remote camera. This is a Wi-Fi camera, which operates, unfortunately, at the same frequency, 2.4 gigahertz, as the output of the Magnetron. So hopefully this will stay connected while we're viewing it. But this is what we're going to use for our remote viewing. And I have a power supply, just a battery. Of course, if the Wi-Fi camera doesn't work, then we're going to resort to our trusty old digital camera right here. Of course, the whole setup's going to be run behind this big garage door to minimize exposure to microwaves. Let's set it up. Okay, here goes. I'm cranking up the voltage on the Variac. Look how the Wi-Fi speed on the camera is decreasing as I crank it up. The Wi-Fi speed is barely enough to make the recording, but look how brightly it's lighting up. I bet that bulb is getting really hot. For some reason, it gets even brighter as I crank down the Variac. Wow, that is hot. Okay, we're now going to test this neon light filming with a regular digital camera. I had to crank the Variac all the way up to 120 volts before it would start putting out microwaves. I'm guessing because of the filament voltage. That bright orange is drowning out everything else around it. I just touched the Magnetron and it's gotten pretty hot. I think it's going to need a fan for extended runs. Thanks for joining me on this video, and hope you enjoyed this experiment running a microwave using a Variac and using the conventional circuit. I think if I had a way of running the filament independently of the microwave oven transformer, this would give me more versatility to decrease or increase the power of the microwaves produced. But anyway, this does show that it will work, and hope you enjoyed it. And if you did and got any comments, please leave them down below, and hope you come back for more videos.